out of that, these three pairs are satisfying the given condition x greater than 1. So this is the relation R. Now how can I represent this relation R using matrix? That is the question. We will be considering the number of elements from the first set as the number of rows and the number of elements present in the second set as the number of columns. We will put 1 if a particular pair is present, otherwise we will mark 0. It will be a pure binary matrix. So let's see what will be your matrix representation. So MR matrix for relation R for the given relation will look like this. We are having 3 elements in the set A, so those are representing 3 rows 1, 2, 3, and I am having 2 columns 1, 2. I observe that pair 2, 1 was present, so 1 is present. Pair 3, 1 is present, 1 is present. 3, 2 is present, 1, and for the rest of the pairs we are marking it 0. So this is the matrix representation. Alternatively, okay, we are having other ways to represent a given relation as well. You can draw a diagram. That diagram is known as a digraph, diagrammatical representation for representing a relation. Let us observe how to represent a given relation using diagram. Observe, we are having only 3 pairs in the relation R, 2, 1, 3, 1, 3, 2. Okay. So first of all, I have drawn a matrix. Later on, if I am representing like a graph is comprised of various points, also known as nodes, and the arrows which are connecting 2 or more nodes with the direction. So as you could observe, there are 3 pairs. So first of all, okay, how to construct a graph for a binary relation? We will be marking the elements present in given set. So I am observing that for A there are 3 elements, so I will have 3 marks, 1, 2, and 3, which will represent the corresponding elements. So we are having 1, 2, and 3. Likewise, we will have again a drawing for elements of the second set if it is existing. So I will have 1 and 2, and then I will certainly draw the edges if that particular pair is present. So I am observing that 2n is present, so I will say 2, 1. Now, if we are only drawing an arc or edge without any direction, that doesn't have any meaning as such, because you already know that 2, 1 is altogether different from 1, 2. So there is a need of putting a direction. If you are putting this direction, that means you will be easily able to interpret the pair in a relation which will be 2, 1 and not 1, 2. In the similar manner, you could have 3, 1. It is possible. Okay, again I will have direction going towards 1, okay, and 3 to 2. Again direction going towards 2. So this is known as a diagrammatical graph in short. Good. If we are having some relation wherein element is corresponding with itself, for example, if you are observing like this somewhere, not for this relation, but if one element is having an arc with itself, this sort of representation is known as self-loop. If somebody is corresponding with himself or herself, we will treat it as a self-loop. So this is new term that you should understand. Remember that if you are not drawing any arrow, then it corresponds to the meaning that you are having both the pairs present. You are having 2, 1 as well as 1, 2 in your relation. Then only you can say that there is no need of any direction as such. Okay. If a node is pointing to itself, it will be known as self-loop. We are having a separate unit, graph theory, unit number 4, wherein we are going to see all the concepts of graph theory. For the time being, just remember that I can represent a binary relation using matrix, or I can represent a binary relation using diagrammatic representation. This is diagram. This is fine. I hope I am audible. Okay. And this is fine as well. Self-loop. Okay. So these points 1, 2, 3 are known as nodes, and these lines are known as the edges or arcs. So we have seen 2 ways of representing a binary relation. One is matrix, other one is a diagram. What is the third way? Okay. Third way is tabular representation. In examination, they will give you this representation and ask you to find the corresponding binary relation. So you must be clear. So if we are representing a binary relation in the form of table, let me draw the table. So this is a tabular representation. I am having 3 rows, so I will have 1, 2, and 3. Again, same like matrix, we are going to put the things. I am having 1, 2, 3 elements of set A in the rows and elements of set B in the columns. Remember that if you are defining a relation on the same set, your rows and columns will be exactly same. Okay. In our example, we are having set A different, set B different. That is the reason why we are taking elements of set A on the left hand side and elements of set B on the right hand side. I am now talking about tabular representation of a relation. You can represent in 3 ways: matrix, diagram, or table. Tabular format. Okay, table. So what to do in case of table? If a particular pair is present, we will mark a tick. Otherwise, we will mark a cross. So 2 to 1. 2 to 1 is present, so I will say tick. That means this pair is present. Then 3 to 1 is present, I will mark a tick. 3 to 2 is present, yes. And for remaining, you can cross or you can keep it blank. Both the options are possible. Okay. Cross may that particular pair is not present. So these are the 3 formats in which you can represent a given binary relation. Am I clear? Should we proceed? Is it fine? Yeah, fine. Thank you. So let's go ahead with, where is my notepad? Yeah. So what are the operations which are possible on matrix? If we are representing a binary relation using matrix, there should be some operations. So operations, addition. In case of addition, are we going to have actual addition? Let's say A matrix is having cell A of ij. I corresponds to row, J corresponds to column. B be a matrix, relational matrix, I must say, having elements B, I, J. Then you would have A plus B. Addition of 2 relational matrices will have a third cell Cij, wherein what are the elements of Cij? Cij will be 1 if and only if this will be binary matrix, remember. So we are not going to perform actual addition. 1 plus 1 will not be 2, 1 plus 1 will be 1, 1 plus 0 will be 1, 0 plus 1 will be 0, and in case you are having both the zeros, then only you are going to have 0. Cij will be 1 if and only if either A of ij is 1 or B of ij is 1 or both, whatever. I must write or both. And this will be 0 if and only if, not if and only if, I will say otherwise. If the initial condition fails, you are going to put it 0. Multiplication. It will be like your normal matrix multiplication. So I do not know what your normal matrix multiplication is. You are better aware of how to have rows and column multiplication and place out the values corresponding. Remember that if you are getting some result of matrix multiplication more than 2, that means you have to keep it as 1 only, because it is a binary relation, binary matrix. Either a pair is present 1 or it is ups. Okay. Otherwise, you will say that, sir, you have told that we are going to perform normal matrix multiplication and we can have any number. No. If you are getting a number larger than 1, you have to keep it only 1. Okay. Let me take out your understanding about this with a couple of examples. So, going further, example number 6, I guess. Let A be a set having entries like 1, 2, 3, 4, 8. A relationship with B. This is other way of representing a relation. No? A relationship with B. If and only if A plus B is less than equal to 9. Find R represent in the form of matrix and diagram. I will not ask for tabular, but in examination they will also ask you for tabular as well. This is the first question. No? First of all, you will be finding relation R and then try to represent in the form of matrix and diagram. Okay. Let D equal to, try to take A always. Let P equal to A comma B comma C comma D and let. Are you able to read this? You will be doing simultaneously. This relations and functions is very vast and we will be requiring around 15 to 17 lectures to finish and we have just started. M of P. M of P means matrix of M of P. I should write M of R. M of R matrix defined for relation R is equal. So here you will be given a matrix. How should I write that matrix? It need to be interpretable to you. Putting 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0 matrix. What is the question? Right. R, I, A, and H. Further to this, construct relational matrix for R raised to 3. Also draw corresponding diagram. If this is clear, you will be able to. I hope you have taken the first example neatly. You would be able to do this as well. Quick exercise, okay, before we proceed for the next point. All other 64, okay, strength is good. Let us check if the same strength remains throughout the lecture. See, I am not having the facility to write this R as a suffix. While writing in your notebook, you should write this R as a suffix to M. M suffixed with R, this is the entire matrix which is given like this. There are 4 rows and 4 columns. But the question is a little bit tricky. First of all, they have asked you to construct relation R. That means you will be writing which are the pairs present in R. You will be further finding what is the domain and range of that R. You will be constructing a relational matrix for R cube. So this requires understanding of composite of binary relation. Then you will be also drawing a corresponding diagram. Any answers in the chat box? What are the pairs present in R? At least can you tell me pairs in present in R? Yeah, many of you have given. Okay. Fine. Good to see that you are responding. Okay. What you are saying? How many pairs? So are you getting 18 pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 12, 15, 18. Very nice. 1, 2, 1, 2, 1, 3, 1, 4, 1, 8. So if you are getting 18 pairs, your answer is correct. While drawing a diagram, it will be a little bit tricky and complicated. So you should be aware of the same. Yeah. Pairs are correct. Okay, fine. Very good. So I'm copying and pasting it on my notepad. What is relation R? Himaya has given the answer. Okay. Himaya as well as Akshara. Akshara has responded first. So how to have its proper interpretation? So let me put that it will be visible. 18 pairs. So these are the 18 pairs. And further, they have asked you to represent in the form of matrix. So while constructing a matrix, okay, how many rows and how many columns your matrix will have? How many rows and columns? So my M of R will have 5 by 5. It will be size of 5 by 5. Okay, and you will be putting 1 if corresponding pair is present. Otherwise, you will be putting C. Ready? 5 by 5. Very nice. Okay, whether all are getting what is ongoing? Whether any one of you has a problem in understanding anything, please feel free to ask me. Okay. If anyone can help about discrete mathematics, that is myself. Okay. So you can ask me for any of your doubts. I'm not saying no one else, but as far as possible, I can help you in the discrete mathematics for sure. And I can again assure you that if you are doing well, you can get 100 on 100 as well. I had a few students in the past while dealing with this subject who have scored 100 on 100 as well. So I hope you have put that 1 and 0 in the matrix. There is no need of having matrix as such here. So you should have that in your notebook. Now let me try to draw the diagram. So first of all I will mark the nodes. So I think nodes are. Now again a question will come. Okay, sir, how can we draw an arc from 1 to 2? Should we draw an arc from 1 to 2 in the same? No. That is the reason why I am drawing over here the nodes. Okay. As I have shown you example, we will be drawing nodes corresponding to sets of a Cartesian product. So for this relation, we have taken Cartesian product of A on A. So this is my first A. I will have few more nodes here for the second A from the Cartesian product. Okay. I hope this is also visible. Green color is also visible. Okay. And if the color is not visible, let me know. I will change my ink. But I take blue. Fine. So let me first of all have here 1, then a 2, then we had a 3, then we have 4, and then we are having 8. Okay. Those who have solved this can take a quick snapshot of this. You can try this. Okay. I will continue in construction of diagram for relation 6. Just take a quick snapshot so that you can work on simultaneously for this. I hope you have taken this snapshot. Okay. Any activities ongoing in the chat box? No. All are listening, I guess. Okay. So here also I will mark for understanding and simplicity. These are the labels of nodes 1, 2, 3, 4 and 8. Okay, fine. Further is what? Now I have to check what are the pairs present. So first pair, have they taken 1, 1? Yeah, Akshada Babre has taken 1. So I already insisted. You can, if you are trying 1 to 1, okay, you could have written like self loop, but here we have taken altogether different nodes representing. So you can draw like this 1 to 1 as well. Now again a question will come, should we have 1 to 1 like this as well? Yes, that is comfortable because we are unable to identify 1 from 1. So this is perfectly fine. Okay. Next 1 to 2. If I am saying 1 to 2, I will have this. Then 1 to 3. Okay. Then 1 to 4. Again, some of you might have a question. Should we draw while representing 1 to 2 from here to here? No need of. We have already covered 1 to 2. So there is no need of again drawing an arc from this 1 to this 2. We have already covered. 1 to 4, then 1 to 8. Those who are having confusions, what was our condition? Condition was a plus b is less than equal to 9. So we are dealing with all those conditions. Okay. Next is 2 to 1. So I will say this is 2 to 1. Again, where should I place? Direction is important. Look, 2 to 1, 2 to 2, 2 to 2. You can have self loop or you may go here. Okay, 2 to 2. Again, it will be a bi-direction. If the element is same. Okay, 2 to 3. And the diagram will become complicated as and when we are drawing additional arcs. Okay, 2 to 3, 2 to 4. So you should draw it properly. I am drawing it on my machine. So it might not be that much perfect. 3 to 1. Arrow pointing to 1. Okay, next is 3 to 2. Yeah, 3 to 2. Next is 3 to 4. I think there. 3 to 4 I have drawn. Okay, next 3 to 3 is remaining. Okay. I have drawn. If not drawn, let me have over here. Again, right direction arrow. 4 to 1, 4 to 2, 4 3, 4 4. 4 to 1. From where to go? So I think you have what I am trying to discuss. You can further draw the remaining arcs. Yeah, fine. Fine. Okay. So let us proceed for this. I am interested now in knowing domain and range of this. We will further require this for computing. So let us write first R. What are the elements of R? Can you tell me quickly? Yeah. Middle AA, AB, BC, BD, CC, CD, DA, DC. Correct. A comma A, A comma B. Only we will consider the entries which are having 1 in their cell. BC, next is BD, next is C comma C, I guess. Next is C comma D. Next is A comma D. Next is A comma C. This is clear. So you will consider number of rows corresponding to elements of P, A, B, C, D. Again, we are not observing any other set. So the same set will act as number of columns as well. On the Cartesian product of P cross P, this relation has been defined, which is having these many pairs. Now we need to compute R cube. How this R cube will be computed? You can first of all specify what is domain. Domain is A, B, C. Only A, B, C. Domain of R. It is not having D. Domain of R. Do we have D? I have forgotten. I think I have misinterpreted this one. should be D comma E, isn't it? And this should be D comma C, is it? Right. A B A A B C B D C C C D D A D C. Yeah. Yes. Obviously, domain will have A B C D. So we have A B C and D. Yes. And range will have A B C D again. So domain and range are the elements of set P. I will not write it further. Okay. So can you tell me quickly what are the elements of R square? R square is nothing other than R composite R. Do not go directly in computing R cube. First of all, compute R square, then take its composite on R. What is R square? If you are getting confused, my suggestion is write this R twice and check out individual pairs. This will not leave any confusion as such. So I have written R twice to compute R square. So I will start from AA. A. What is the new pair form? A comma A. Next, A, new pair form is A comma B. A, nothing else. Okay. C, new pair form is A comma C. D, new pair form is AD. AB, nothing else. Okay. Let us go for BC. C, you will have B comma C. D, you will have B comma D. Okay, I think C is over. Now I will have pair B comma E. Next, okay, BDDA is over. BDDC, I will have pair B comma C. This is perfectly fine. Okay, yeah, this is making sense as well. CC. So have we considered CC? CC. Does it make a sense? Making a sense is important. Okay, I have covered up to this. Now we are going here. CC. We have to pick up an element which is starting with C and present in R. It will form a new pair CC. CCD. Do I have any CD? No. So I will have CD. Next, CC. Nothing. Okay. CD. CDDA. So I will have C comma A. CDDC. So I will have CC, which is already over. So I will not again write CC. Okay. So CD is over. DA. DAAA. B comma A. DAAB. B comma B. Okay. I think we are starting with the AR over. DCCC. D comma C. We taken D comma C. D comma C. DC. DCCC. DCCD. So DD. DC. Okay. How many of you are able to get this as your R square? Can you reply quickly in the chat box if you are able to get these pairs in your answer of R square? Can you reply quickly? Just cross check. Are you getting total 15 pairs in your answer? How many of you are getting 15 pairs? These 15 pairs in your answer of R square. If you are getting, then only I suppose that you have understood, otherwise there is a problem. If you are able, now I am not going to compute R cube, you will be telling me the pairs of R cube directly. I have done for R square. Tell me directly pairs present in R cube. R cube taking R square on R. Any answers? I'm asking, I'm waiting for R cube. We have a lot many things to cover. Can you reply? In R square, is there BC twice? Have I written BC twice? Yeah, yeah. It was my mistake. Okay. Good to know that you are keen in checking out my solutions. Very nice. Okay. There should not be any repetition in relation. You should have distinct pairs only. So there should be 14 pairs in R square. At least can you tell me the number of pairs present in R cube, cardinality of R cube? We have a whole lot of examples for people are leaving and again joining. So all are computing, but so still the time you compute, I will have something drawn over here. So I think what should I do? Page. Where it is? Page by the way. Page. Page. Yeah. So in the meantime, you complete. I have questions for you. This is question number 8 that I am drawing over here. So do it. See, writing this A, B, C inside a circle or outside a circle is a matter of choice. You can write beside the node or inside the node as well while constructing a diagram. No problem at all. So example number 8, figure I am drawing in front of you. You need to write corresponding relation for this diagram. A diagram is given and relation is asked. This is example number 8 and example number 9. Let me. This is only for your practice. Okay. I know that you will be able to, but still we are taking. This is 2. Okay, so these are the two examples that you have to try after finishing your. Okay, what is the question? A digraph is given. Find the relation determined by the following diagram and also give corresponding matrix. So you can take this as an exercise. I am not going to discuss. Okay. Yeah. 17 elements in R cube. Yeah, okay. 17 elements in R cube. Whether all are getting 17 elements in R cube? Whether all are getting 17 elements in R cube? Okay, Viraj has given the answer for this diagram. I guess it is AA, AB, CA, CB, DC, DD. Is it? Yeah. Yes. So if you are getting 17, again you can cross verify with me by querying personally. Okay? I hope you have computed R cube as well. And for this, we will have relation like 1 to 2, 2 to 2, 2 to 3, 3 to 3, 4 to 3, 4 to 5, 1 to 5. Okay. Over to next point now. So you should get number of pairs in R cube as 17 and you should draw its corresponding matrix as well. So matrix is asked, I guess. Construct relational matrix and also draw corresponding diagram. So you should deal with it. Okay. So next, there are few properties. Relational matrix. Let R1 be a relation, obviously binary, okay, a relation from A to B, that R2 a relation from B to C. The following properties hold true. M means matrix of R1 composite R2. This should be in suffix. I am writing together. While writing in notebook, you should write in suffix. M of R1 composite R2 is equal to M of R1 multiplied by M of R2. M of any, okay, M of R converse is equal to transpose of M of R. R should be in suffix. Okay. Third property, M of R1 composite R2 whole converse. Converse is applicable for R1 composite R2. Okay, not for matrix. I am saying. So we will first compute R1 composite R2, then take its converse, and then you are going to construct a matrix. This is equal to M of R2 converse composite R1 converse. M of R2 converse composite R1 converse. This is further equal to M of R2 converse multiplied by a matrix multiplication, M of R1 converse. You will ask me, sir, how can you prove this? So for the same, we are having one example. Let take a quick snapshot of this. Example is big, okay. So that you will have these properties in your notebook or somewhere down there. Let example number 11, I guess. A equal to 1, 2, 3, 4. R1 equal to, relation is given 1, 1, 1, 2, 2, 3. 2, 4, 3, 4, 1, 4, 2. So R1. Okay. Compared to this, R2 is also given. So it is 3, 1. How that relation is defined, we don't know. Okay, relations are also given. 3, 1, 4, 4, 2, 3, 2, 4, 1, 1, 1, 4. What is the question? Verify the properties of relational matrix. Other, I should say, verify all the properties of relational matrix. So that means we will be verifying all those three which are mentioned here. So be quick. I think I will verify first two and you will be verifying third one as well. The first two I will try. I will show you demonstration as well. Those who are understood can go on writing in the notebook. Okay, how much is the count? Yeah, 64. So people are joining, I guess, because it is now in the concluding phases and you will have your attendance. So people are joining. Earlier it was 62 or something. Now we are having 64. Fine. Okay. So what is first? Matrix of R1 composite R2 should be shown to be equal with matrix of R1 multiplied by matrix of R2. So let us check out whatever it may be. First of all, I need to compute R1 composite R2 to have. Okay. So what is R1 composite R2? 1, 1, 1, 1. So I will have 1, comma 1. I repeat, if you are not understanding anything, feel free to ask me. This is very crucial and will give you out of score. 1, 1, 1, 1. Okay, done. 1, 2, 2, 3. I am going to have, okay, I think 1, 1, 1, 1, 1, 1, 1, 4. So we are going to have 1, 4 as well. 1, 4. Fine. Then what else? Nothing. 1, 2, 2, 3. So I will have 1. 1, 2, 2, 4. So I am going to have 1, 4. Okay. 1, 2, 2, 3, 1, 3. 1, 2, 2, 4, 1, 4. Okay. 2, 3, 3, 1. So I will have 2, 1, 2, 3 over 2, 4, 4, 4. So we will have 2, 4. 2, 4, nothing else. Okay. 3, 4, 4, 4. So obviously I'm going to have 3, 4. Okay. 3, 4, 4, 4 over. Okay. 4, 1, 1, 1. So I'm going to have 4, 1 in the result. 4, 1, 1, 4. So I'm going to have 4, 4 in the result. Okay. I think 4 is over. 4, 2. 4, 2, 2, 3. 4, 3. 4, 2, 2, 4, 4, 4. We have already covered. So we are going to have 4, 3. Have we taken 4, 3 anywhere? No. So I'm going to have 4, 3. Because of pair, 4, 2, 2, 3 results in 4, 3. Okay. Fine. This is my entire matrix. So fine. Now let me construct the LHS. LHS is what? It's a matrix of R1 composite R2. Obviously, I'm going to have 4 elements in the rows 1, 2, 3, 4, and I will have 4 elements in the column 1, 2, 3. So 1, 1 is present. So mark 1. 1, 2. Do we have 1, 2? No. 0. Do we have 1, 3? Yes. Do we have 1, 4? Yes. Next. 2, 1. 2, 1 aayega? Yes. 2, 2. 2, 3. Do I have 2, 3? No. Do I have 2, 4? Yes. Next. 3, 1. 3, 1 is absent. Okay. Do we have 3, 2 somewhere? 3, 2? No. Do we have 3, 3? Hardly. Do we have 3, 4? I guess yes. Next. 4, 1. Do we have 4, 1? Yes. Do we have 4, 2? I think no. Do we have 4, 3? Yes. Do we have 4, 4? Yes. How to cross check? Count number of pairs in R1, composite R2, 1, 2, 3, 6, 9, 10. Do we have 10 ones in this matrix? 1, 2, 3, 4, 5, 6, 7, 8, 9. One is remaining. Which is that? One is remaining. I see 2, 1, 2, 4. I have marked 3, 4. I have marked 3 plus 3, 6 plus 3, 9, 1. Which one is remaining? Any guesses in the chat box? Which one is remaining? 1, 4 repeat. 1, 4 taken twice. Okay, 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 fine. Fine. Good. That means the matrix is correct. Okay, 1, 4 is taken twice. Very nice. Viraj. Okay. Now what is RHS? RHS we have to multiply individual matrices. I'll say RHS is M of R1 multiplication M of R2. This question has been asked for 6 marks in university examination for several years. Okay. What is this? What is M of R1? M of R1 is, I think, 1, 1, then 1, 2, then 3 is not there, 1, 4 is also not there. Okay. Do we have 2, 1? 2, 1 is not there, 2, 2 is not there, 2, 3 is there. Do we have 2, 4? Yes. Then 3, 1. Do we have 3, 1? No. Do we have 3, 2? No. Do we have 3, 3? No. Do we have 3, 4? Yes. Then about 4, 4, 1 and 4, 2 are present. Okay. 4, 1, 4, 2 are present. Rest are 0. So I have drawn matrix for R1. This should be in multiplication with. This should be in multiplication with R2. So what are the elements of R2? Let me make it. I have shown you for first. Now this should be shown. R2. So we are having 3, 1. What are the pairs for 1? 1, 1 is present. I guess 1, 4 is present. Okay, if I am correct. Then for 2, we are having 2, 3, 2, 4. So first 2 are 0. 2, 3, 2, 4. Then for 3, we could hardly observe this one only. Remaining are 0. Okay, and for 4, I guess for 4 we are having 4, 4 only. Okay, so these are the two matrices. Now let us apply the normal matrix multiplication. So 1, 1s are 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. So first pair will be 1. Okay, first row, second column, all zeros, 0. First row, third column. I'm observing 1 somewhere. Okay, first row, fourth column, 1 is present. Now observe, first row, fourth column, 1, 1, 1 plus 1, 1, 1. It will come 2. But still you are going to take it as 1 only in multiplication. Okay. Next, second row, first column. Second row, first column, 1. Second row, second column, all are 0. So obviously we are not going to have anything here, 0. Okay. Second row, third column, I think 0. Second row, fourth column, I think 1. Correct me if I am going wrong. Okay. Third row, third column, 0. Third row, second column, 0. Third row, third column, 0. Third row, fourth column, 1. Fourth row, first column, 1. Fourth row, second column, 0. Fourth row, third column, 1. Fourth row, last column, 1. Now let me check out how many entries we do have. 3 plus 2, 5, 5 plus 1, 6, 6 plus 3, 9. Do we have the same entries in LHS? 1011, 1001, 001. Let me check it. 1011, 1001, 0001, 1011. Absolutely fine. So as LHS is equal to RHS, our formula number 1 is clear. Repeat. Okay. So which one should I repeat, Rohan? Rohan, which one should I repeat? Is there any need of repeating matrix multiplication or any point? Let me know. I have done normal matrix multiplication, nothing else. If you require repetition of something, it was a previous step. Okay, no problem. So first example is clear. I am going to solve second. Third one I am not going to try. You will try. Okay? So what is transpose of a matrix? We are interchanging rows with columns, isn't it? So what is the second property that is given? If we take a converse of any relational matrix, it will be equal to transpose of original. Obviously, you are going to change. Just observe what is the transpose of M of R1. What will be its transpose? So 1001 will now come in row and 1100 will come in column. So that will be transpose. Interchanging rows with columns. Okay, fine. Till you are solving, I will have your attendance. Okay. Is it fine? Is it fine? Do you have any difficulties so far? Let me know if you are having difficulties so far. Anything to discuss? No problems?